All right, so we just went over the synthetic division. Let's take a look at number 2, which is simplifying expressions with imaginary numbers. So the first thing we're going to do is simplify that I to the 15th and I to the 85th. So we look at 15 and we say, hey, 4 goes in there 3 times, and the remainder part is the important part. So what's the remainder? 3. So I to the 15th is really equivalent to I to the 3rd. All right, I to the 85th, it goes in there completely 21 times, and the remainder is 1. So I to the 3rd has a value of negative I to the 1st is just I. And then we distribute, and we say, hey, I got an I squared. I squared is going to change that sign. Hey, I got an I squared. It's going to take that negative 1 and make it a positive 1. And then simplify. Any questions about number 2? All right, number 3. Now, on Friday we talked about what I felt you should be responsible to know. This is a 4th root, so we're just thinking of things to the 4th power. 2 to the 4th is 16, 3 to the 4th is 81, 4 to the 4th is too big. I can quit thinking. Okay? 2 to the 4th is the same as 4 squared, right? Let me change colors. 2 to the 4th is the same as 4 squared, as 3 to the 4th is the same as 9 squared, as 4 to the 4th is the same as 16 squared, as 5 to the 4th is the same as 25 squared, right? Because this is 5 squared squared. This is 4 squared squared, right? So I don't even memorize my 4th powers because I know my squares. I'm good. All right, so which one goes into here? 81 does. 81 goes in there twice. And then we have x to the 8th, y to the 10th, z to the 15th. So then I can start taking, and I just wrote the answer twice. The first time it was kind of a little scrunched together. The 81 comes out, and I get the 3. 4 divides into x to the 8th. What it really is x to the 8th to the 1/4. That's why I'm thinking 4 divides into it, because it becomes x to the 8 divided by 4. So 8 divided by 4 goes in evenly twice. 10 divided by 4, I get 2, but it leaves 2 under with my remainder. And 15 divided by 2 goes in 3, but it leaves 3 under with the remainder. So my answer is 3x squared y squared z to the 3rd times the 4th root of 2y squared z cubed. How'd you do? Good. Excellent. Okay, let's, I think I had a change here. Or did we even get this far in this class? Didn't even get this far. All right, pull out this. Let's go over it. Okay, yes. Yes. They should be over here in the notebook where I put my Okay, so if we take a look at these, we talked about closure on Friday, and those of you that weren't there, the definition was written at the top. Set is said to be closed under particular operations if the result of those operations is also in the set. So if we add 2 natural numbers, we get a natural number. So yes, it is closed. If we subtract natural numbers, do we always get natural numbers? No, because 3 minus 4 is negative 1. If we multiply natural numbers, we always get natural numbers. And if we divide, we do not. Now, sometimes, and you may have Googled this, sometimes when we look at this, they will say all non-zero. And if we say non-zero, it eliminates that whole possibility of dividing by 0. Did I say non-zero? No, I just said all of them. So 0 still played into account on these. So anytime we can divide by 0, it's going to be no, right? All right, so whole numbers was yes, no, yes, no. Is that what you guys got? All right, integers, did you get yes, 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 no?
Yes.
Excellent. Rational numbers, yes, 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 no. Because 2 divided by 0 is undefined. So if my directions had said non-zero, then this would be yes, because that's our only situation where it gives us something that is not rational. But I didn't say non-zero, so we had to think about 0. All right, irrational, no, 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 no. Complex. All right, let's think about complex for what it is. Complex has two parts. It has a real part and it has an imaginary part. And both parts are contained within complex. All real numbers, therefore, could be labeled as complex. It would be a real number with an imaginary part of 0. So it would be a real number plus 0i. And all imaginary would fall into that because we could just have 0 plus the imaginary. So if I gave you a real number, you could also classify it as a complex. Or if I gave you any imaginary number, you could classify it as complex. So when I add, I get complex. When I subtract and when I multiply. But if I had this division, I divided by 0, or anything divided by 0, that would be the one part which would keep it from being closed. Does that make sense? All right, and then the polynomials. Yes, 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 no, because this is not a polynomial. It is not a polynomial here because polynomials have to have whole number exponents. And this variable right here could be written as x to the negative 1, couldn't it? So I do not. You can't have division by a variable and still have a polynomial. Yes?
If you multiply 2i times 0, wouldn't that become not closed? I mean, not closed?
It's still closed because 0 is a complex number.
Oh, right.
Okay. All right, let's take a look at your book work. My copy allotment likes the book.
Oh my god.
I like those. That's pretty.
No kidding. Actually, no, we're not.
Actually, they're not. They're not the same.
Exactly.
Like you have a huge area of green, and she has.
My friends let me, right?
I got slower.
All right, any questions? Yes, ma'am.
Well, you did 22.
I will talk you through 22. Okay, what does this mean? This means the opposite of 36 to the 3 halves. Now, if it meant negative 36, it would look like this. But this means the opposite of 36 to the 3 halves. Well, the 3 halves could be written as the 1/2 to the 3rd. The 1/2 raised to the 3rd. Well, the 1/2 power is the same as square root, isn't it?
Yes.
And the square root of 36 is 6, and 6 to the 3rd is 216. And that opposite is still out there because it's the opposite of.
I got it like, I don't know why.
How'd you do it?
I don't know. I don't know if it was like right, and then I erased part of it.
Okay.
So,
Well, you don't have to do it this method.
will you look at it later?
I sure will. Okay, what else on this front page?
10.
Number 10. Okay, the cubed root of 16 over x cubed. All right, this is how I would think of it. As the cubed root of 16 over the cubed root of cubed. And the cubed root of x cubed is just x.
Right.
So we're good. We do not have a radical in our denominator. We do not have to rationalize. But we do have to simplify the numerator. And a perfect cube that divides into 16 is 8. 8 times 2 is 16. So the cubed root of 8 is 2. And it just leaves the 2 under there. So it's 2 cube root 2 over x. Make sense? All right, anything else? All right, let's move on. Okay, now you can still see 26, but it's 26 through 50.
I'm looking at some of these. How did I get some of these? 42. Honestly, for 42, I'm pretty sure I was just like random answers. So.
Well, power to a power, you multiply. And when you multiply reciprocals, it's always 1.
It's 1. I'm a genius. I just went with my gut. 5.
Genius
How?
works out well sometimes.
How? Oh, I think I
No, it could just be 7. Yes. All right, well, it's written right here. All right, 46 to the negative 1/2. Okay, let's think about what a negative exponent does. A negative exponent does reciprocal, doesn't it? Okay, so it's already written as a fraction, which is nice for us. So we do the reciprocal of 1 over 25, and we get 25 over 1. If 1 is the denominator, do we need to write it?
No.
No. So it's really just 25 to the 1/2. And the 1/2 power is the same as the square root. So the square root of 25 is 5.
I thought just like.
I got it.
Okay, what else? All right, number 50. Anytime we take a number and divide it by itself, it equals 1. Or you can think of it as division of like basis is the same as a subtraction, and 7 to the 0 is 1. Any number to the 0 power. Yes, ma'am?
For number 38, why wouldn't you add the denominators?
On number 38, when you multiply like basis, you add the exponents, and when you add fractions, you have to have a common denominator, but the denominators don't change. Anything else? Okay. All right. Today what we're going to do is we're going to spend class time working on your review. All right. Your test is Friday. It's not Friday. That's my other class's test. Your test is Wednesday. Today we're going to start the review. Tomorrow we're going to go over the review, and then you're going to test on Wednesday. Now, what I'm going to do is the moment the bell rings, maybe even, probably as soon as the warning bell rings for a break to be over, I'll let you begin your test. So, as soon as the warning bell for break rings, you can start your test.
I'm going to get here early on Wednesday.
Yeah.
Right
Well, I started to tell first period that I'd let them start their test as they walk through the door. And I was like, wait a second. They'll get here at like 8:15. That's not fair. The test? It is completely doable. But if you choose the more difficult way to work every problem, it would take you the whole class. Like if you choose long division when synthetic would answer it quickly,
I'm still going to do it.
you may not finish.
I'll battle it out. and just get it done.
Is this about the same length?
I took the test and
I'll try it.
yes, it worked.
Wait.
Zero three, looking at the test.
Wait, is it on
Yeah, like what we're doing for now. It's the degree.
That actually tried it.
Okay, you know how I told you you had to know the special names for degrees up to 5?
Yes.
Okay, I think I may have misguided you and pretended like that was the only special names. There are special names over 5. We're just not going to name them that way. Okay? You could call them like a 6th degree. Could be what is 6?
Miss Willoughby? Say we lost a special name sheet. Where could we find this?
On my website, my notes are all there.
Like at the moment though.
Well, that's what it asks for. It just asks
Yeah,
for it.
clearly, yeah.
And then here, right here, it asks you to name it.
Right there.
She did call it a bill.
Yeah.